Okay folks, this is the second part of our counting principle video. We're going to focus on permutations and combinations and the multiplication and addition principle in the fundamental counting principle. So first of all, the multiplication principle says the following. Let me just collect my highlighter. There we go. The first operation can be done in m ways, the second operation in n. The total of number for both operations to be done simultaneously is m times n. Okay, so that's what we've been looking at so far. You multiply every single option that you have with one another and then you get your final product. But the addition rule says something else. If a certain operation can be performed in m ways and another can be performed in n ways, then the total number of ways in which, look at that, which, misspelt, either of the two operations can be performed is m plus n. Let me just assure you that's not me. This I got from a website. Okay, so either of the two can be then performed by m plus n. Okay, so if you've got 5 boys and 4 girls and you choose a captain for the team, it's a debating team, then you've got 5 plus 4 choices, which is 9 choices. You simply just add them together. Now here we have a nice question. We've got a question that says from 25 students, you have to choose a leader first of all for the SRC. Okay? And then after that you choose 2 deputy positions, 2 of them with a condition that one be filled with a male and one with a female. So you have to choose out of a pool of 25 for president of the SRC. Okay, so in total, let me grab the pen. There's a choice of 25 people. You choose your president, then there's 24 of them left. Now, okay, this now depends on whether we choose a male or a female. But of the 24, that's male and female, we then have to choose one of them from the female side and another of them from the male side. So we had 25 choices for president. Okay? Then 24 choices to choose from, or actually not 24. It depends on what was chosen here, but we're going to throw them all in the pool there. And we're going to choose a female. Now remember the females, if the female, we can make this quite technical. Let's just discuss it in general. For 24 left, 1 chosen. For 23 left, 1 chosen. So it looks like your options are 72 in total. 72 ways that you can choose. But now, if we have 10 males, and we have 15 rather. Where's my eraser? My eraser's there. We have 10 males and then we have 15 females. So let's say the president was chosen and the president was male. Okay? So in the beginning you had 25 choices. The president was chosen to be a male president. So there's 9 choices left to choose from for the deputy, and there's still 15 choices left to choose from for the second deputy. Okay, so again, if we start off, there's 25 to choose from for president. President can be male or female. If we chose a female, that leaves us with 10 males to choose from when we choose our deputy president. And it leaves us with 14 females. Now folks, if you look at that, it leaves you with 24 options. And here it also leaves you with 24 options. So the total number of options available to you here is 49 ways in which that can happen. Okay, let's look at another one. There are 3 scholarships that must be awarded to 5 candidates who take science, or 3 candidates that take biology, or 5 candidates it takes maths. 3 scholarships. In how many ways can the 3 scholarships be awarded? Now folks, the 3 scholarships in general can be awarded by the product of the 3 choices. There's 5 candidates that take science. Where's my highlighter? There's 3 candidates that take biology and 4 candidates that take maths. So in total, you have 5 times 3 times 4 choices. This would mean that you can choose all 3 from there, or all 3 from here, or all 3 from the 4th pool. There's 60 ways in choosing who you award the scholarships to. In how many ways can one of these scholarships be awarded? Okay, so this is all 3, and here we're just awarding 1. Well, that is simply just the sum of the 3. 5 plus 3 plus 4. You need to choose 1 out of one of those pools. You've got 5 to choose from, for that take science, 3 biology and 4 maths. So there's 12 ways in which to choose one scholarship. Okay, that's the difference between the product and the addition rule. Here's another question. A room has 6 doors. There they are. 1, 2, 3, 4, 5, 6. In how many ways can a man enter the room through one door and go out through another? Well, let's see. To come in, they say there's 6 options. So he can come in through every door. He comes in through any one of the 6 doors. But to go out, there's only 5 options. So in total, there's 6 times 5 options to do this. Let's see. Comes in there, then he can go out in any one of the other. And that process is repeated 6 times. He can enter through 6 doors. Okay. The next question, we just moved myself away there. Find the number of 4-letter words that can be formed from the letters ROSE, R-O-S-E, without repeating a letter. The word does not have to have meaning. So there's 4 letters. That's the crux of this question. There's 4 letters that we need to choose from, and of the 4 letters we need to make a word. And not have meaning is key, okay? And there's also no repetition. So if I put the R here, there's 4 letters, so I have a choice of 4 letters there. I'm not repeating. If I were allowed to repeat, then I have 4 choices here, 4 choices here, 4 choices there. So for the second one, 1 letter is removed, so there'll be 3 choices. For the third, there'll be 2 choices, leaving us with 1 at the end. And what are we doing? We are multiplying all of these. That's the total number of ways in which those 4 letters can be rearranged. It doesn't have to have meaning, so it's just a matter of there's 4 letters, rearrange them in different ways. Okay, so here we're going to call this, we're going to give it a name, we're going to call it 4 factorial. 4 factorial is simply just 4 times 3 times 2 times 1. If there were 6 letters, it would be 6 factorial ways that we can arrange them. Okay, so very important that you understand the shortcuts as well. Okay, so there was 4 options. 4 options gave us 24 words, which is equivalent then to our 4 factorial. Now, if repetition was allowed, then we had 4 options for the first letter, 4 for the second, 4 for the third, and 4 for the fourth. So our result would be 4 to the power of 4, which is 256 words that can be made by rearranging those letters in such a way where you can repeat. Now again, you can see it's a huge difference when we allow for repeat and when we don't. Let's talk about permutations and combinations. Both these ideas need the concept of the factorial of a number, and we've just spoken about it. The definition of n factorial is simply just n multiplied by the number before n, multiplied by the number before that number, and then multiplied by the number before that number, before that number, before that number. So it will be, if this is 5 factorial, there we'll have 5 times 4 times 3. Before the 3 we have a 2, before the 2 we have a 1. So it's those 5 numbers multiplied in that sequence. Okay, so there we go. Excuse me, it's exactly what I wrote down there. So 5 factorial is 120. Now a little bit, a few principles that we might use in our work going forward. One of them is that you can write n factorial as n times n minus 1 factorial over there. Okay, so those two things mean exactly the same thing. That is what we're saying over there. And then naught factorial is equal to 1 by definition. Remember this. If you see naught factorial is equal to 1, and there's a definition that tells us that is true. So n factorial grows rapidly and can lead to overload on your calculator. If you go and type in 100 factorial on your calculator, it might still be able to calculate that. But go and put in 1250 to the power 10 factorial, you'll have a problem. I think you'll even have a problem. Let me check on my calculator here. If I put in 100 factorial, it will give me the answer. No, already there it says there's a problem. Okay, so remember, it grows rapidly. So you might just be able to calculate on your calculator up to a specific point. Let's see how it works. 8 balls are put into a hat and drawn out randomly. So we're working with 8 balls and the draw is random. One by one we draw them out without putting them back. Now folks, this without putting them back means there is no repeat choices of balls, okay, because the ball that was chosen is out. How many possible different arrangements can these possible balls make? Now there's 8 balls, so it will be 8. We've taken it out. The next ball is chosen from 7, the next from 6 left, the next from 5, that's actually a multiplication, the next from 4, and it continues like that until you draw the last ball. So total arrangements, there's 8 slots. Possibilities per slot, 8, then 7, then 6, then 5, then 4, 3, 2, and 1. Okay, what are we doing? We're multiplying them. So it's 8 factorial ways to choose that 8 balls without putting them back. Okay? If we were putting them back, it would be 8 to the power, there's 8 balls in the bag and there's 8 slots. So it'd be 8 to the power of 8 if we only draw a ball and put it back. So our total number there will be 8 to the 8. And if I put that on my calculator, 8 to the power of 8 is, oh my goodness, 16.8 million ways to choose the 8 balls. 167777216. Okay, very interesting. If we don't allow for repeat, there's only 40,320 ways to do that, to draw 8 balls from a bag. Can you believe it? Without repeating. And it's a random draw. Consider the set of letters A, B, C, and D. How many 2-letter words can be formed by these letters if 2 different letters have to be used? So you've got A, B, and C. Now let's talk ourselves through this. There's A, B, okay, then there's A, C, and then there's B, C. How many 2-letter words can be formed if 2 different letters have to be used? So again, 2 different letters are used. So we cannot have a AA, a BB, and a CC. Okay, there's no repeat of a letter in each word. So it looks like there's 3 words that can be formed. Now let's see how do we calculate this and if we are indeed right. Listing all possibilities shows that there are 6. There are AB, BC, AC. But then we can also choose them the other way around. BA, CB, and CA. So in other words, AB and BA, AC and CA, BC and CB. So the order of the letters were only restricted by the fact that they can't be the same. We can choose either AB or BA. So there's 6 possibilities for us to do this. Okay, so if A is Albert, B is Ben, and C is Clint, how many 2-man crews can be made up from the 3 gents? Now that, folks, is an equivalent question to ABC. Okay, but here, when you put Albert and Ben in a... So here, the order of the choices mattered because there was no context to A, B, and C. But now there's a context. There's 3 men. So you can choose Albert and Ben, then you can choose Albert and Clint as a team, or Ben and Clint. But if you choose Clint and Ben, I mean, hello, it's the same 2 men. So in this case, there's only 3 teams that can be chosen. Albert, Ben, Ben and Clint, or Albert and Clint. So read your question carefully when you do the selections. Okay, the selections of these things are really very, very important. The way in which you select what it is that you're working with. Okay, what's the difference between a permutation and a combination? Sorry, I just need a piece of paper here to work on. So for a combination, we select. For a permutation, we arrange. So permutations are arrangements, okay? And here we are selecting. So ARR for arrangements. Now, if you arrange things, order does matter. But if you select, order doesn't matter. So if we looked at the 2 questions we had previously, the ABC question, the one was an arrangement. So it was a permutation, just making up words from the 3 random letters A, B, C. But combining, in other words, selecting men to work on teams was smaller, okay, because there the order did definitely matter. But with a selection, the order doesn't matter. With a permutation, it does. Okay, so the one is an arrangement. So if you're arranging, you're working with a permutation. If you're selecting, you're working with a combination of things where you select things and orders matter. So let's see what we say. Both problems involve counting the numbers of arrangements. The set of ABC, taken 2 elements at a time without repetition. Okay? No repetition allowed. However, in the first problem, the order of the arrangements mattered, since A, B, and BA are 2 different words. So there the order was very key. In the second one, the order didn't matter, since A, B, and BA represented the same 2-man crew that we counted. I think this example exemplifies the difference quite nicely. So the first example was concerned with counting the number of permutations. Remember, we said for permutations, the order matters. We are arranging things. Then it's a permutation. So the three objects were taken, taking 2 at a time. The second example was concerned with counting the number of combinations of 3 objects taken 2 at a time. So here the order does not matter. You can take A, B, or B, A, it means the same thing. It's Albert and Ben, or Ben and Albert is exactly the same thing. Then we're talking about a combination. So with combinations we basically select, and with permutations we arrange things. Now let's look at a few permutations. Let's remove myself there quickly. Noting P, N, R. This is the way we write it. They write it in very different ways. So let me highlight things. Yeah. PNR represents the number of permutations. So in other words, the number of arrangements. Think of PA, a personal assistant. Permutations, arrange. There's N objects to arrange, and you're taking R at a time, where R is less than or equal to N. Okay? So the notation PNR represents the number of permutations or arrangements of N objects taken R at a time, where R is always less than N. You cannot take 5 objects, take 5 objects if you only have 3. You cannot take more objects at a time than what you have. So you can't take 5 objects from a list of 3 objects. Okay, there's got to be more objects than the ones you're going to select. So N is always bigger than R. Okay, so a permutation, the order is important. Okay, let me move myself away there. In the example of the set of ABC, okay, where 2-letter words were formed, the answer was P32, which represents the number of permutations of 3 objects taken 2 at a time. And that is 3 times 2, which means the number of permutations is 6. So what is it? It's N times R. There was 3 objects. I need to take 2. N times R. In general, N times R, or the PNR would be N times N minus 1 times N minus 2, N minus 3, until you get to N minus R plus 1. Okay, so let's see. N minus R here would have been 1, and 1 plus 1 is indeed 1. So this is what this statement means here. Okay, PNR means basically N factorial, but you stop the N factorial when you reach N minus R plus 1. Okay, let's see. With that in mind, there, we need to find P53. So if we write down what we know, pen, P53 will be 5 factorial, which is going to stop at 5 minus 3, okay, which is 2 plus 1. So 5 minus 3 is 2 plus 1, it stops at 3. So 5 times 4 times 3. So what is not there? 2 times 1 is not there, folks. Okay, so how can we write this differently? We can say it is N factorial divided by 2 times 1 is N minus R. If this is N and that is R, this will be N minus R. Oops, that's a bracket. Factorial. Okay. So that would mean it's 5 times 4 times 3 times 2 times 1. n minus r is 2, so you divide by 2 times 1. That and that takes care of each other. So it's 5 times 4 times 3 that remains. Okay? So I think I discussed that. So let me just remove this with my eraser so we can see exactly what it is that I discussed with you guys on the slide. So yeah, 5 times 4 times 3 is 60. So there's 60 permutations of 5 items taken 3 at a time. Okay, find P55. Now, okay, that is simply just 5 factorial if we think about it, because 5 minus 5 is 0, plus 1 is 1. So it starts at 5 and it finishes at 1. Okay, so that's simply just 5 factorial. There's 120 ways to do that. Now remember, here you have 5 objects and you choose of the 5 objects you want them to be arranged in different ways, taking 5 every time. Okay, so there we go. Taken 5 at a time. So it's simply just, because it's an arrangement, PA, okay, permutations are arrangements, okay, we have that as 5 factorial. Then we have a park bench, can seat 4 people. How many seating arrangements are possible if 3 people out of a group of 7 sit down? So let's just summarize what it is that we have. We have, where's my pen? There. We have 7 people that we want to sit down for. Okay? So it's a permutation of 7 and we want to use 4. Okay? We can choose them randomly. Doesn't matter how we choose them. We have a random choice here. So this will be 7 factorial according to our rule, divided by 7 minus 4 factorial. 7 minus 4 factorial, and that's just simply 3 factorial. So this result will be 7 times 6 times 5 times 4. 3 factorial divides 3 to 1 away. Okay, let's have a look. So think about the park bench. It has 4 slots. You sit down 1, there's 6 left, then there's 5 left, then there's 4 left. So it's the product of those 4 numbers. And we can write that product like I did over there. So it is 7 times 6 times 5 times 4, which is there's 840 ways. Look at that number. To seat 7, from 7 people to seat 4 at a time. Very interesting. Okay, so permutations. Let's look at a bookshelf. A bookshelf can take 8 books. In how many different ways can 12 books be arranged on this shelf? So order doesn't matter here, so it's a permutation. Okay, remember, a permutation, in a permutation, order does matter. We're arranging things. So PA, arranging, there's 12 books in total, and I want to choose, of the 12, I want to choose, that doesn't even look like an 8, I want to choose 8. Okay, so 12 factorial divided by 12 minus 8, which is 4 factorial. Okay, in how many different ways can 12 books be chosen? How many different ways can 8 books be arranged on the shelf? So here we saw 8, choose 8 is just simply 8 factorial. This one here will be 12 factorial divided by the 4 factorial, the difference between the two. Okay, so if we have that, you'll see we stop here. We don't have 4 times 3 times 2 times 1 because we're dividing it away. So from 12 to 5, look at the amount of arrangements. If I put a comma there, it's 19,958,958 1,400 books. Okay, there we go. Okay, folks, so that is the answer to 1. The answer to the second one is because we need how many different ways can 8 books be arranged on the shelf. We choose the first book, it's 8, second book 7 ways, third book 6 ways, and then the rest follow as we complete our arrangement over here. Okay, let's look at another one. So there are basically 2 types of permutations. There's permutations where repetition is allowed, and there's permutations where there's no repetition. Choosing a 3-digit combination for a lock where repetition is allowed is simply just, if you have 9 digits to choose from, 9 choose 3. Or if it's actually it's 10 because it starts at 0. With no repetition, here you have, for example, first 3 people running in a race. You cannot be first and second at the same time. So there's no repetition allowed there. Where for these, you can repeat numbers. Well, I suppose it depends also on what the problem says. So here we go, and this is what I've been showing you all the time. PNR can be written in 3 ways. An N at the top, a P, and then an R, or an N and an R either side and the bottom of P, but either way means it's N factorial over N minus R factorial. Permutations with repetition is simply just N to the R. These are the easiest to calculate. When a thing has N different types, we have N different choices every time. So if we have to choose R times, it's N times N times N, R times the choice. So N to the power R is simple exponential. Permutations without repetitions are different. In this case, we have to reduce the number of the variable that are available every time a choice has been made. Instead of writing the whole formula, we can then do that. Okay, here we go. There's videos for you to watch. If you want to take a screenshot of those 2 and watch the videos, I think I used the second video in what comes next. So let's talk combinations. Combinations are different. Combinations are things where we select and the order does not matter. Okay, so if we want to form pairs of men working together from a collection of 3, we found there are 3 pairs. So it's a combination of 3 choose 2, which again is written either like that or a 3 and a 2 there. There's different ways to write these things. If we want to find the number of combination of 3 objects taken 2 at a time, we simply divide the permutations that we could of 3 choose 2. Let me read what I've written here. We simply divide the number of permutations of 3 objects choose 2 at a time by 2 factorial. Excuse me, because we choose 2. So this means the following. Let me put the rule down here for you. If you have C, N, choose R, then they're saying it is the number of total choices as if it was a permutation, N minus R factorial. Okay, that would be the permutation. And then we choose R, so we multiply the denominator with the R factorial. So that's the combination. It's a permutation that's divided by the number of choices factorial that we're working with. Okay, so 3, with that in mind, 3 choose 2 will be a permutation of 3 choose 2 divided by 2 factorial. So it's 3 times 2 times 1 divided by 2 times 1. So it will be 3 only. The 2 times 1 and the 2 times 1 cancel one another. Okay, so there is the rule. That is basically the general result for a combination, and it is the way I wrote it previously over there. N factorial divided by r factorial divided by r factorial times n minus r factorial. So this rule gives a number of subsets of size r that can be taken from a set of n objects. The order of the items in each set does not matter. Order does not matter for a combination. The number of combinations of n distinct objects taken r is n factorial divided by r factorial times n minus r factorial, if we use this rule as it's written over there. So C85, we can write it differently. Let me write the alternative here for us. C85. I'm going to try and write it as nice as I can. C85 will be 8 factorial divided by the number you choose multiplied by 8 minus 5 factorial. So that part there is the permutation multiplied by 1 over the number of choices that you're taking. Okay, so it works exactly the same way. So where P88 was 8 factorial, C88 will simply be 1, because it's 8 factorial divided. If you look at this second one, it's literally 8 factorial divided by 8 factorial, which is indeed 1. Okay, so let's have a look. In how many ways can you choose 6 out of 10 friends to invite to your birthday party? Well, here, folks, why is it a combination? Because order does not matter. The order in which you choose here does not matter. Okay, then it's a combination. So it's 10 choose 6. So if we were to write down a rule for that 10 choose 6, let me just get my pen. My mouse doesn't want to work nicely now. What's going on here? There we go. So my pen for 10 choose 6, or my calculation, will again be 10 factorial divided by the number of choices I had multiplied by 10 minus 6, which is 4 factorial, and that's going to give us this 210 choices that we have. Okay, combination or permutation. We've got to choose which one of the two am I working with. In how many ways can you arrange 10 books on a shelf that only has space for 5 books? You want to take 10 books, and you only have space for 5. So here you are arranging PA. Remember, permutation is arrangement. Okay, so it is a permutation of 10 choose 5. So it will be 10 factorial over 10 minus 5 factorial. So this calculation is 10 factorial, the number that you choose, nr, this is n and this is r, over n minus r, which is 5 factorial. And that result gives you the number of arrangements that you can make. Okay, let's see here. Why is this a combination? A lottery consists of selecting a set of 6 numbers, okay, randomly from a set of 49 numbers. To win this lottery, you must select the correct 6 numbers. Okay, so there's 49 choose 6. How many possible lottery tickets are there? Now, folks, here, please, it is a selection, so it's a combination. Selections are combinations. Arrangements are permutations. Okay, selections, S or C. S and C. Selection is a combination. Remember it that way. Okay, so here we have, this is based on 49 factorial, which is a heck of a lot. Let me tell you how much it is indeed, if my calculator can deal with that. 49 factorial is, listen to this, 6,0828161864 times 10 to the power 62. 10 to the power 62. That is one huge number. Okay, then I've got to choose 6. Okay, so that changes it a bit. And then that is the difference between the two. So there, the difference between 49 and 6 is 43 factorial. Now let's see how much that gives us. Oh, the answer is on the screen. It's 139. So every time you go and play the lotto where you have to choose, select 6 numbers, you have, what is this? This is 13,983,816. Okay, there we go. That's the amount of combinations that can come out of that selection. Okay, again, we're looking combination or permutation. You want to create a company logo which consists of 3 circles, which must be colored in 3 of 6 colors. Colors may not be repeated. Okay, colors may not be repeated. How many ways can you create the company logo? Well, here order does matter. A flag with colors A, B, C is different from a flag with colors A, C, B. We find, therefore, permutations. We're selecting colors. Okay? Permutation. We're arranging colors on a flag. So permutation, which is arrangement, there's 6 available, we need to choose 3. So there's 121 or 120 ways in which this can happen. On the calculator you will press 6, then shift, and then shift you'll press the x to the power minus 1 button to get to the factorial. Or if you look at your calculator, above the multiplication and division sign you'll find NPR and NCR. So you press 6 and then shift the NPR button and then press 3 and the result comes out. Okay. The next one, permutation or combination. Let's see. You want to create a set of signals using 5 different colors. Each signal consists of 2 different colored flags. How many signals can you create? Now here again, the order is important. So it's AB or BA is a different signal. Okay, a signal with colors AB is different from a signal with colors BA. So we have 5 colors we want to select. 2, it's a permutation. We want to arrange them in 2. From 5 we want arrangements of 2. Okay, so there's 20 in total. A coin is tossed 5 times and the outcome is recorded. How many different outcomes are there? Well, every time you toss a coin, there's an outcome of 2 that's possible. Okay? So if you toss it 5 times, the result is 2 to the power of 5. Because with any one that's happening, there's an outcome of 2 that's possible. Okay, and that just simply becomes 2 to the 5. Now here, mixed problems where we have repetition allowed and repetition not allowed. How many 2-digit even numbers can be formed from the number set 1, 2, 3, 4, and 5? 2-digit even numbers, okay, where repetition is allowed, and the numbers are 1, 2, 3, 4, and 5 are the numbers that are available. Okay, so we know for 2-digit even numbers, this here, the second digit, repetition is allowed. The second digit, for this to be even, the second digit must be even, and there's only one of two choices there. So there's two choices left for the last number. For the first number here, we have 5 possibilities that we can choose from. Okay, so it's either a 1, then 22, 32, 42, 51. So in total there's 5 times 2 ways to choose it. There's 10 possibilities. Okay, if repetition is not allowed, then we have a problem. Because if we need to choose our 2 digits here, well, there's only one of 2 digits that will make it even. So we've removed one of them here. So there's only 4 available for the first digit. So here we will have, actually, if there's 4, the digits may not be repeated. That's correct, yeah. So there's 8 options that we have. So if we put, let's say, the 2 here, then there can still be a 4 there, the number 4. That can be a 1, a 3, a 4, or a 5. But this must be a 2. If this was a 4, this could be a 1, a 2, a 3, and a 5. So the number of options available, if it's not allowed, is 8. Okay, and folks, there's your summary of everything that we've discussed in the second lesson. Please, if repetition is allowed and repetition is not allowed, there's 2 different things happening. Okay, so for a combination, if repetition is allowed, for a combination, if repetition is allowed, yeah, then that's your formula that we spoke about. If repetition is not allowed, then at the top you'll have n plus r minus 1, because you're not allowed to repeat. And at the denominator, you'll have r multiplied by n minus 1 factorial. So this formula, please remember it. Very important that you commit these to memory when you work with permutations and combinations, where things are allowed to be repeated and where things are not allowed to be repeated. I hope, folks, that helped you to gain a better understanding of the counting principles that we work with in mathematics. Okay,